Hi. So this question says a point is represented by 3, 4 in the Cartesian coordinate system. Express this in the polar coordinate system. So what we're going to do is a conversion from one coordinate system to another. So let's first of all visualize what's going on. So here's our Cartesian coordinate system. We have our x-axis, we have our y-axis. Our z-axis goes, the positive z-axis comes towards us out of the screen. We don't need to worry about that. We've only got two coordinates here. Let's do a quick diagram. So we have 3 units along the x-axis, and we have 4 units along the y-axis. And if we extend these lines up, we see our point of interest, P, is at this point here. Um, What it wants us to do is express this in the polar coordinate system. And the polar coordinate system is slightly different. We have the arm, R, that is the distance from the origin. And then we have the angle from the positive x-axis. So we need to convert from xy component system into an r theta system. And if we think about it, we can see some geometrical shapes that are coming. In order to find this length r, I'm going to rely on Pythagoras' theorem. And Pythagoras' theorem says that c squared equals a squared plus b squared. It's the right triangle, so that means that r squared is equal to 3 squared plus 4 squared. R squared is equal to 9 plus 16. R squared is equal to 25. So R is equal to the square root of 25, which is plus or minus 5. We know this is going to be just a positive 5 is going to be our answer. So this is going to be 5 units long. And frankly, many people who work an awful lot with right triangles learn the standard forms for these. And there's a standard form, which is the 3, 4, 5 right triangle. If you have one length that's 3 and another length that's 4, and the hypotenuse is 5, you know it's a right angle. Well, that's half the problem done. We know how to figure out the length of this, but what about the angle? And to get the angle, what we recognize is that the tangent of that angle is equal to the opposite over the adjacent. And in this case, this is the opposite, and that's the adjacent. So as far as this problem goes, tan theta is equal to 4 over 3. So theta is equal to tan to the minus 1 of 4 over 3. And if you go to your calculator and work out this angle, this will equal 53 degrees. So we put these two guys together and we say 3, 4 in the coordinate system, in the Cartesian coordinate system, gets converted into 5, 53 degrees. So there's our answer, 5, 53 degrees. So looking up here, that would be choice C. And there we have it.